This is neither a crime branch nor a scene out of a suspense film. This is the office of the Chief Medical Officer, or the CMO, from where an inspection team is leaving for inspecting the food being sold or produced in the market. Food inspectors frequently visit the places of sale, storage or manufacturing units of food products to ensure their quality. The entire procedure of collection of food samples and their testing is laid down in the Prevention of Food Adulteration Act, PFA, of 1954, in which subsequent amendments have been carried out to make it foolproof. This action is taken as a routine check as well as on receipt of complaints. PFA also specifies the standards to which all food products have to conform. The CMO can assign any inspector to go for sampling, accompanied by a deputy CMO or a team. The inspectors must make their intentions clear of having the samples analyzed for contamination and adulteration.
Come, sir. Come, Inspector Sahab. We've got everything here, sir. Good quality products.
Oh, that's okay. We'll check for ourselves.
Hey, Chotu, get some cold drink.
No need for the cold drinks. We'll check all the products.
Inspector Sahab, you look at all the products. They've got everything. Manufacturing date, expiry date. You can take anything. It's all there.
Yes, we'll check the products on that side.
No. Inspector Sahab, why don't you look here, sir? Come, look here.
No, we'll check that later. First, we'll go to the other side. We'll take the sample of this and also this. We'll take it for testing.
Inspector Sahab, no, please listen to me. No, sir.
Each sample is collected in 3 lots, individually marked, labeled, sealed and packed in the presence of the shopkeeper or producer, as the case may be. The quantity of samples for each product as well as the procedure of collection, sealing, packaging, filling up of memorandum forms, countersigned by the shopkeeper and dispatch are carried out as specified in the PFA.
These products are tested for contaminants, adulterants and also food colors that can be detrimental to health. Some of the colors are actually banned due to their toxicity. They can lead to retardation of growth and also affect some of the vital organs in the body. The heart, the lungs, the kidneys, the spleen, the liver and also the bones and the immune system.
The samples are then sent to the local health authority, who then check the seal, forms and ensure that they have not been tampered with. The samples are then entered in the logbook along with the name and address of the supplier and given code numbers for fair testing and anonymity. One of the samples is sent to the public analyst, while the other 2 remain with the local health authority. The sample is received through mail. Memorandum of the sample comes by a separate mail. Both are entered in separate diaries. When a sample is opened, a form is filled up which contains all the details pertaining to that sample, like date of receipt and dispatch, number of sample, demand draft number, name of the sample and the sample code number. The code number is on the outside as well as the inside of the sample. The seal is tallied. After verification, the sample is given a folder number. Last of all, it is entered in the sample entry register. The fee register bears the following details: folder number, demand draft number, date, amount, received from, and memorandum number. Samples are given fresh code numbers and handed over to the analyst for testing.
Our team collected 5 samples: milk, turmeric powder, pulse, in this case arhar dal, mustard oil and carbonated water. We're going to test these samples one by one in the laboratory.
Milk is tested for total solids, fat content, presence of urea and starch.
When a milk sample comes to the lab, it is tested for various adulterants. Primarily, it is tested for starch, sugar, fat, also total solids and SNF. Excess moisture or water, if added to milk, curd or paneer or any other foods, is hazardous to health only if it is contaminated, because it can lead to gastrointestinal disturbances.
Total solids. A clean aluminium moisture dish with the lid is heated in an oven for an hour at 100 plus 2 degrees centigrade. It is then cooled in a desiccator and weighed. Few drops of milk are put in the dish. The dish is then put on boiling water bath without the lid until the water evaporates. The dish is placed in an oven. The lid is then put on the dish and cooled in the desiccator and weighed. Oven drying procedure is repeated till it reaches constant weight. The Gerber test for fat content. Gerber method test is carried out to determine the fat in the milk. Fat is an important indicator of the quality of the milk. Pure milk has higher fat content. In order to test it for fat content, 90% sulfuric acid is poured into a butyrometer tube by automatic dispenser without wetting its neck. Then a few drops of milk sample is mixed into it gently with a milk pipette. This Gerber butyrometer is calibrated to 6% fat. The isoamyl alcohol is added, the locked stopper closed, and it is shaken until homogeneous. It is then inverted to complete the admixture of the acid. It is kept in the water bath for 5 minutes at 60 degrees centigrade or more, taking care to see that the particles dissolve fully. The Gerber tube is then put into a centrifugal machine for 4 minutes at 1100 RPM. 2 tubes are put in it opposite each other in order to maintain balance. The butyrometer tubes are then taken out and the percentage of fat is read by adjusting the height in the tube by movement of the lock stopper with the key. Test for urea. In the milk sample, a few drops of 1.6% dimethyl aminobenzaldehyde solution is added. If there is added urea in milk, it will show a distinct yellow color. The presence of natural urea in the milk produces only light yellow color. Test for starch. Milk sample is taken in a test tube to which a drop of iodine solution is added. If blue color appears, it indicates the presence of starch or SMP, that is skimmed milk powder. Turmeric powder.
Turmeric powder is tested for moisture, total ash, ash insoluble in hydrochloric acid, presence of lead chromate, another artificial coloring matter like metanil yellow.
Total ash. First, an empty platinum dish is weighed. Then sample of turmeric powder is put in it. The dish is put in a muffle furnace, heated at 550 degrees centigrade. It is allowed to be there for approximately 3 hours until completely ashed. After cooling, it is weighed again. The difference in weight is the total ash, and its content should not be more than 9% of the total weight of the turmeric powder. Ash insoluble in dilute hydrochloric acid. To ascertain ash insoluble in dilute hydrochloric acid in turmeric powder, the total ash mixed with dilute hydrochloric acid is boiled and filtered through an ashless filter paper, washed with distilled water and then ignited on burner. It is again ashed in a muffle furnace. As per PFA, it should not be more than 1.5% in weight. Artificial coloring matter like metanyl yellow. Turmeric sample is mixed with small volume of water. Then a few drops of hydrochloric acid are added to it. In the presence of artificial coloring matter, the turmeric powder turns magenta pink in color. If the color persists on dilution, there is presence of artificial coloring matter.
Metanyl yellow is one of the most commonly used water-soluble yet non-permitted dyes to color foodstuffs. It is also carcinogenic, and the consumption of this can affect the stomach, the ileum, the liver, the kidneys, the rectum, and also a lot more. The symptoms of this are weakness, giddiness, vomiting, and also cyanosis.
Presence of lead chromate. The turmeric powder sample is first completely ashed in a platinum dish in a muffle furnace, dissolved in 1:6 sulfuric acid and boiled. Freshly prepared 1:2 diphenyl carbazide solution in alcohol is put in the test tube along with the sample. In the presence of chromate, magenta color appears, whereas pure turmeric powder does not give any color. Lead chromate presence should be negative.
The presence of lead chromate causes lead poisoning. Symptoms of this are stomachache, nausea, constipation, and anemia.
Presence of moisture.
Presence of moisture is tested by toluene distillation method. Turmeric powder is taken in the distillation flask or moisture apparatus. Sufficient amount of toluene reagent is added to it.
The moisture apparatus is heated and allowed to distill for 2 to 3 hours. The water collected at the bottom of the tube is measured. If the moisture content is found to be more than 13%, it is deemed to be adulterated. Mustard oil.
Mustard and other vegetable oils have been found to be adulterated with argemone oil. Now, this is very toxic and in the past has led to widespread poisoning outbreak. It results in a disease called dropsy, which is characterized by edema or swelling of the ankles, also changes in the blood vessels, changes in the eyes, and heart problems. When cheaper or other adulterants like mineral oils or castor oils or cheap inedible oils are used, then it could lead to nausea, vomiting, and also have laxative effects. Prolonged use of the same can also have effects on the intestine. If these are used over a long period of time, well, they also affect the absorption ability of fat-soluble vitamins like vitamin A, D, E, and K.
In order to test its purity, mustard oil is first put through a physical examination in the laboratory. It is checked for clarity, presence of sediments, suspended or foreign matter, separated water, etc.
Mustard oil is tested for saponification value, unsaponifiable matter, iodine value, presence of argemone, and also the turbidity temperature, known as BTT.
Saponification value. A sample of mustard oil is taken in a flask. Alcoholic potassium hydroxide solution is pipetted into the flask and the sample is saponified. The same process is repeated simultaneously with a blank, that is, without the oil sample in the flask. The flasks are cooled and titrated with hydrochloric acid, adding phenolphthalein indicator. At the end, the pale yellow color turns pink. The saponification value is defined as the number of milligrams of potassium hydroxide required to saponify 1 gram of oil or fat to neutralize fatty acids. The permissible SAP value is 168 to 177. If the SAP value is lower or higher than the specified limit, it means the oil is adulterated. Iodine value. 2 simultaneous tests are carried out, one with oil sample and the other one blank. Adequate quantity of mustard oil sample is taken in a collared neck conical flask with a glass stopper to which a small amount of carbon tetrachloride is added. The contents are well mixed and pipetted into a few drops of Bridges solution. Glass stopper is wetted with potassium iodide solution and replaced. The flasks are rotated properly and kept in the dark for 30 minutes. Potassium iodide solution is added to the blank, followed by water, rinsing the stopper also. Liberated iodine is titrated with standardized N by 10 sodium thiosulfate solution using starch as indicator. If iodine is present, it shows a dark color. It is thoroughly shaken with the stopper on until the blue color disappears. Iodine value of an oil or fat is a measure of unsaturation. Iodine value is the percentage of iodine absorbed by the oil or fat under the conditions of test. Iodine value indicates the unsaturation of oil. The permitted iodine value is 96 to 112. Below or above this, the mustard oil is adulterated. Presence of argemone.
In order to test the presence of argemone oil, we take some filtered mustard oil in a separating funnel and dissolve it with diethyl ether.
Small amounts of hydrochloric acid is added to it and shaken vigorously for 2 to 3 minutes and then put to rest so that the acid layer can be separated. The acid layer is transferred to a beaker. The residue is dissolved in 9:1 chloroform acetic acid and spotted on the TLC plate with the help of a capillary. Simultaneously, standard argemone oil extract is spotted on the TLC plate and developed in hexane and acetone solvent system. The solvent front is allowed to move up 10 centimeter distance and then the plate is dried in room temperature. The dried plate is then viewed under long-wave UV light. The presence of argemone gives bright yellow or orange-yellow fluorescent spot. Turbidity temperature is tested here through acetic acid method. With the help of a pipette, filtered oil is measured in a long-necked, round-bottomed conical flask and mixed with filtered alcoholic potassium hydroxide and saponified for 10 minutes. This is done by heating over a boiling water bath using air condenser. The droplets of oil disappear and the liquid becomes clear.
On cooling, when phenolphthalein indicator is added, it turns pink.
It is neutralized by adding acetic acid twice, drop by drop. Small small amount of 70% alcohol is added and mixed. A thermometer is fitted into the flask in such a manner that its bulb is immersed in the liquid but does not touch the bottom of the flask. The flask is heated until the temperature reaches 50 degrees centigrade and the solution becomes clear. The flask is then shaken often while cooling in air to 40 degrees centigrade. This is to ensure that the temperature falls roughly at the rate of 2 degrees centigrade per minute. The temperature at which turbidity appears is noted, and this is the turbidity temperature. For mustard oil, the permitted turbidity temperature is 23 to 27.5 degrees centigrade. Carbonated water.
Carbonated water is tested for artificial sweetener and artificial colorant. The non-alcoholic beverages which are impregnated with carbon dioxide are described as carbonated water. And the first step is to check the tamper-proof seal of the sample bottle of carbonated water. The next step is to go on and check for any suspended matter. There are 7 basic permissible colors. If the color is unidentifiable, then the carbonated water has a color adulterant.
Artificial sweetener. We are looking for the use of saccharin. A small amount of carbonated water sample is put into a separating funnel. Hydrochloric acid is added to it. After acidifying the carbonated water, solvent ether is added into the separating funnel. It is shaken well, and in a short while, ether layer is separated. Aqua layer is drained out in a separate glass basin. After evaporation, the residue obtained is taken for a taste test. At first, it tastes sweet and then sour. This means that saccharin is present in the sample. Artificial color. 70% alcohol is added to carbonated water. This colored water is allowed to concentrate on a boiling water bath. Strands of pure wool are dipped into it and squeezed. The colored water is boiled so that the color remains in the ammonical water solution. The wool is taken and washed thoroughly. It is again boiled in water, to which a few drops of ammonia are added to make it basic. If color is present, it releases itself in water. The extracted color is spotted on a chromatographic paper. We reach the conclusion that the given sample contains artificial color.
Pulse, in this case arhar dal, is tested for moisture, coal tar, synthetic color and water-soluble color. Now first of all, the inspection is carried out using a magnifying glass to check for insect infestation, also rodent hair, maybe any kind of other contamination or any other kind of material which is visible to the naked eye.
Often toxic pulses like Lathyrus pulse used to adulterate tur dal or arhar dal can cause the crippling disease Lathyrism if consumed in a large quantity over a period of time.
It begins with the stiffness of the knees, the ankles and the legs, and finally leads to paralysis of the lower limbs.
Moisture. The measured sample is taken in a pestle mortar and ground for determining moisture content and transferred to the measured moisture dish. The dish is kept in an oven at 130 to 133 degrees centigrade for 2 hours. It is weighed again. The loss of weight is the moisture content that was present in the dal. Test for water-soluble synthetic color. A measured quantity of arhar dal is put in the conical flask and 70% alcohol is added to it. It is kept overnight and filtered so that the color is extracted in alcohol. It is filtered through the funnel in a beaker. This colored water is allowed to concentrate on a boiling water bath. Strands of pure wool are dipped into it and squeezed. The colored water is boiled so that the color remains in the ammonical water solution. The wool is taken and washed thoroughly. It is again boiled in water, to which a few drops of ammonia are added to make it basic. If color is present, it releases itself in water. The extracted color is spotted on a chromatographic paper and run in a suitable solvent system. We reach the conclusion that the given sample contains artificial coal tar color or any other poisonous seeds. Certification. After the tests are systematically carried out and the results obtained, the director of the testing lab issues a certificate which contains the result of the test. If the tests are positive, that means the product is found to be non-standard. The report is sent to the supplier. The party is free to go to court in appeal against the verdict. If so, the local health authority is obliged to provide another sample from the two lying in its custody for testing by the lab determined by the court, and the same process is repeated.
So as you saw, these were some of the tests that were run on the 5 basic products of daily use to ensure their quality and their purity to safeguard our health.